Activity 2, we are told that the mean length is 41.5. Standard deviation is 2.5. What is the probability that the random sample of 50 is drawn will have a mean of between 40.5 and 42 hours? Shiloh, are you there now? This is a question that you're asking about. This question has a specific sample size attached.
Yes.
Says if a random sample of what? Of 50. So meaning our Z in this case, formula will change, will be X minus what? Mu standard deviation over square root of what? N. Right together. So what are we given here? Mu is what? The 1.5. Standard deviation, 2.5. Our N, 50. You have to find between 40.5 and 42. So what are we given? A mean 41.5. Our range 40.5 and what? 42. Our standard deviation is what? Our standard deviation is 2.5. But our standard error is 2.5 because our N is 50. So our standard error is standard deviation over square root of what? N. So here we're going to have square root of N, which is 50. So when we divide that, we're going to get 0.3536. Are we together? So I mean to find Z, it is X minus mu over the error. We need to standardize this guy here. What is the Z for 40? So we did 40.5 minus 41.5 over the standard error, which is what? 0.3536. So in this case, when you compute that, you're going to find as negative 2.83. Negative 2.83. So this one is equivalent to negative 2.83. This is at 0. The 42, we're going to say 42 minus what? But 1.5 over the standard error, which is 0.3536. When you divide and compute, you're going to find 1.41 positive. And what we do, we read from the tables. This one and this one, what are they equivalent to? 1.41. And you go into the table and negative what? 2.83. So 2.83, negative 2.83, 2.8, and a 3, 1, 2, 3. What do we have? 0.233, which is 0.233. The difference. Then here we get 1.41. We go to under 1, 14, 1. This is 9,222. 9,222. So when you get the difference between these two, what you're actually going to get is our difference. So we're going to get 9184. So this is the difference between those two, and exactly how we arrived at this answer. Are we together? Malulu, are we
Yes.
together? Okay.
Mr. Collins.
When finding the difference, do you switch the numbers or?
Yes,
I
of
noticed
course.
that in
Bigger number
the
minus
box.
smaller number, yeah.
Oh.
Yeah. Obviously, when you're 20% and 50%, you can't subtract 50 from 20. Just subtracting a bigger percentage minus a smaller percentage. It's a difference. Can I proceed?
Yes, Mr. Collins. I just wanted to know, this is still on probability, isn't it?
This is still a normal distribution, yes. Okay.
Okay, I was just trying to look at how many questions we have on probability.
Probability is widespread, so you need to.
That's fine.
So here we're told that the CEO of a life insurance company has undertaken a survey, and he wants to make sure that the yearly profit has a standard error of not more than 1.5% of the mean. And the mean we're told is 800 and standard deviation is 300. What is the sample size? So sample size has how many formulas? There's 3 formulas. Give me the formula for sample size. Number 1, n is equal to z squared.
S squared over E.
Number 2, n is equal to what? S squared over what? E squared. And the last one, n is
N or sigma.
standard over the standard error squared. So these are the 3, and you need to know when to use which formula of these 2. So in this question,
Mr. Collins, what's the difference between the first one and the second one?
The first one, but who wrote this one here? Chiluba, what are you doing on the board? So this is the PQ. I think this is what I wrote, It's PQ. Somebody is tampering with my board. All right, is this clear? So this n is coming from the standard error, which is simply given by standard deviation over square root of n. When the n comes aside and they swap, so meaning the square root of n will be standard deviation over standard error. Then when you square both sides, the n is what comes to be this. It's just coming from this standard error formula. So I'll summarize it for you. So now we are told that our standard deviation is 300 and our mean is what? 800, and our standard error is 15% of 800. So what we do, our standard deviation is 300. Our standard error is 15%, or 0.15%. So times what? 800. So this is giving us what? 12. So what sample size is required? Our n is simply 300, which is standard deviation over 12. Then you square it. So 300 over 12 is 25. Then square 25, we're going to have 600 and what? 605 policies. So our sample size should be what? Should be greater, it should be less or equal to 625. So the question was asking us here, how large should the sample size be if we don't want to have more than 1.5 errors? So we use the sample size formula, not less than 1.5 of 800. So this is equal to 12. Then when you calculated that, cross multiply, this comes here and this comes there. So we're going to have our 12, we divide on both sides, 12 into 300, the square root of n. So 12 into 300 is 12. So it's 25. Then you square on both sides. 25 on both sides. So you're going to have n. So the sample should be at least 625. That is the minimum sample size that we need for us to do what? Less than 1.5 error. So it's the same thing that I've done here, but in a simpler way. So this is how we find our sample size. So it should be at least what? 625 policies. Right together? Okay, we proceed. Part C, a manufacturer is determined from experience at 3% defective. So even this is normal distribution, but proportions. In the middle, we have what? 3%. Then we're told that 3% are defective. A random sample of 300 watches is examined. A random sample of 300 watches is examined. So our N is 300. Any questions so far? So we are given a sample size. So we need to calculate the what? The standard deviation, the standard error. Are we following?
Yes.
So we're trying to calculate that if a random sample of 300, since we've been given n, we need to calculate the standard deviation for the proportion. What is the probability that proportion will lie between 2% and 3.5%? So we're looking at this proportion here. Okay. Are we together?
Yes.
All right. So in this case, we're going to now standardize. So our standard error, our standard deviation is what? PQ over N square root. So our P is what? 3%, so 0.03. Our Q is what? Our Q is what? 97%, so 0.97, right? Divided by N, our N is what? 300. So calculate for me. What are you getting?
9.848.
0.9.
9.
Yes.
0.0. Yeah.
It's 9.8. Oh, there's 0. Mine is saying 9.84. The zeros in front, sorry, but it's 9.848.
Which is 0.00984.
When you multiply times 100 in percentage is what? So you're going to find 0.0098.
0.0098.
So this is the same as 0.98%.
Mhm.
Okay. So
Alright.
using percentages. So standard deviation will be what? 0.98%, right? Are you together?
Yes.
Okay. Yes.
Excuse me, Mr. Collins. Mr. Collins,
Yes, please.
I wanted to find out how you can set the calculator not to be giving me answers in exponential.
You need to press mode 3 times. Then when you see normal is on button 3, you press 3. Then you choose option 2. I thought I healed all your calculators in class.
Come again,
Well,
Collins, please.
Some of us still
You
have
press the
got to do
mode
it.
3 times. Then you see normal. Under normal is on option 3. You press option 3, then to give it to options 1 or 2, you choose option 2. Are we there?
Yes,
Okay.
thank you.
So now are we together on the 0.98%?
Yes.
So let me go through the question now again. This question was tough, but I've simplified it the Collins way. So a manufacturer has determined that 3% of the watches are defective. So our mean is what? 3%. That's where the 3% is. Are we together? Then we are also told that a random sample of 300 watches is examined and the portion defective is between 0.2 and 0.35. So meaning that 300 is helping us calculate the standard error or standard deviation in short. It's equal to PQ over N. So our P was 3% times the Q. So 0.03 times 97%, 0.97% over N 300 and square root. The standard deviation you're going to get is 0.98%. I'm sure everyone has gotten where we're getting this. Then we're being asked, what is the proportion, what is the probability that we're going to range between what? 2% and 3.5%. These are just in decimal points. So just put it in. So between 2% and what? 3.5%. So we're looking at this shaded region. So let's standardize the 2%. You can even remove the percentages if you want. So it is 2 minus what? 3 over 0.98. What do we get? Then here is 3.5 minus what? 3 divided by 0.98. What are you getting? There you're going to get negative what? Negative 1.02. So 0. Then there we're going to get what? Positive 0.51. So these ones, you read them in the table. What is 1.02 in the table and 0.51? So negative 1.02, and go into the table. Negative 1.02, so negative 1.0 and under 2, 1.0 under 2, 0, 1, 2. So this is 15,386. So this is 15,386. Then 0.5, when we go into the table, under 0.5 what? 0.51. 0.5 under 1, 64, 49.7. 64, 49.7, is it? 64, 0.51.
Mr. Collins, isn't it 69?
69, 497.
Mm-hmm.
69, 97. Is it? 69,
Yes.
97, yes. Then when you subtract them, what are you getting? These two. When you get the difference, what difference are you going to get? 5411, isn't it?
Yes.
Yes, yes.
So 5411. So this is how he must have gotten this, except that he didn't show this jargon. Very few of you would understand what was happening here, but I've just simplified the jargon there. What we get?
Let me see your solution again. Just take a screenshot.
Okay.
Okay, thank you.
So we now go to another question. This was the last question in this. Okay, this one. Please, it will tire your mind. Just memorize it if you want. I want to look at something else. So dominated so much on one topic.